Alright, hello, welcome. This video will go over a review for the Chapter 6 test on arrays part 1. This chapter is actually split into two parts because it's a long chapter. But this video is just going to be a bunch of review questions. Have out pencil paper, try the questions first, and then on pause the video to check your answers. So your first one is up there. What is going to be displayed by this code? Okay, and again, hopefully you've had a chance to try this before watching the solution. I think it'll be much more meaningful than just watching me do it. Okay, so we're going to loop through, and we're not doing every number here. We're doing a sum, right? We start at 0, and then we add the ith number to it each time, and then we print it out. But we don't go from 0 to the end like we normally do, right? So we start at index 1, and then it goes up by 2. So we're going to do the first index, the third index, the fifth, the seventh, and we go while we're less than nums.length, so that's normal. So we're going to round all those to the end, and 9, we won't hit 9 because that's too far, and there's no number out there anyways. So it's just basically going to do nums position 1, right? So it's going to access like nums position 1, which is 2, right? And then so forth and so on. Nums when I is 3. Sorry for the terrible handwriting there. That's a 0. And then nums position 5, etc., is 7. And then the last one, nums position 7, is 14. And it's going to add all those values together and print out the sum, which in this case would be 13. Right? So it's the sum of the elements or the values at 1, 3, 5, and 7. Okay, so here's a question that I just want you to focus on the algorithm. I feel like the code of this would actually be really hard, but this is good just to think through like the different algorithms, and it will be somewhat helpful for that test tomorrow. This is actually true that a teacher, when they retire, they end up getting paid the average of their top 5 years, their top 5 salaries, right? So this is kind of a small array because I don't want to make a huge one. But if you had a huge array and you had to find the top 5 salaries and then average them, how on earth would you do that? So this is a good chance for you to pause the video and see if you could come up with a good algorithm for this. All right, so there's actually 2 different algorithms, and I think the best one is not all that intuitive, especially because we haven't talked about it. But one option is you could put them in order from greatest to least, and then you could just sum the top 5 positions and then return step 2 divided by 5, right? That would be the best and easiest ways to put them in order, right? But that's not all that intuitive, especially because we haven't talked about ordering numbers yet. So the other route I thought you could do is you could like find the highest number and add it to a sum variable that started off as 0, set that value to 0, right? So it's no longer counted as the high, and then repeat steps 1 and 2 4 more times, right? So basically you could keep doing that, right? Because then you'd have a new highest value each time. As long as you set that position to 0, then you'll get a different high value each time. And then you could do the take that sum and divide it by 5 at the end, right? So 2 different ways, kind of interesting. I think that is actually is how teacher salaries are calculated. Retirement salaries are. Divide sum by 5. Right, so that's the way I would do it. I think this red one's much better, but if we hadn't, if you didn't think of ordering them, the way in the green way would also work. Okay, here is a more traditional one. We have a method that's going to reverse the array, so it takes an original array. It looks like it makes a reverse array, which is the same length as the original. Okay, and then see if you can figure out what is wrong. So pause the video and give it a shot. All right, so when I first look at this, my guess would be the indexes. So I have index I that's looping through the original, starting with the last position and going greater than or equal to 0, minus minus I. So that actually looks right. And we're going to take that ith position. And then the reverse index, so we're going backwards through the original and putting it in the forwards order in the reverse. So reverse IDX starts off at 0. All right. Oh, and it looks like that's my problem. So at first I thought the problem, actually I see two problems now that I'm looking at it. So anyways, it is storing the ith value here in reverse index, but then we need to manually change this reverse index, right? Otherwise it's going to keep copying to position 0, which is what reverse index is initially. So we need to make it go forward so that it puts it in the next spot each time. So for the reverse index, I need to manually change that where I is going to change in the loop from this loop counter here at the end. So that's the error. And then another minor one I just realized is that this should be int bracket bracket. If we're going to return the array reversed, I need to return an int array, not just an int. So there's actually two errors on that one. Okay, sorry for the confusion there. All right. So, what do you think's gonna be here? I don't want to give too many hints. I'm just gonna let you give it a shot before going through the answer. Okay, so just to draw it out, remember arrays are pointers. So when you do this new int array, it's gonna make an array with two elements at the 0 and 1 position, both of which are 0. Okay, and then the next two lines are gonna set these values. So position 0 will now have a 5 and position 1 will have a 10. Okay, and when you do int b equals a, remember what happens is b is actually going to point to the exact same memory as a is. So that when I set b of 0, that really sets that spot for both arrays because there really is only one array. Right? Even though they have two different names, they're both pointing to the same spot. So this is now 6, so that if I print out a position 0, it's going to be 6. Because it was actually changed. A position 0 was changed right here, right? Oh, sorry, I messed that up. Apologies. All right, so that's just testing that you realize that arrays are pointers and they both are pointing to the same spot in memory here. Okay, sorry for the confusion. So a lot of this is about loops, right? So we want one here that displays the odd values. Okay, so not the odd positions. Remember, there are two parts to an array, right? And what you see here is called two things. It's called the elements or the values. Okay, and then you have positions and indexes. So those are just labeled starting with 0, going up by 1. Okay, and those green things are called, sorry for the bad handwriting there, those are again called indexes or positions. Okay, and so your job is to sum the odd values, not the odd indexes, but the odd values. So pause the video and see if you can figure out the code here. You could type it up, you could write it out, however you want to do it. Okay, so here you go. So I just have to display them, so I don't need a sum variable or anything. But I'm actually going to loop through all of them. So I'm going to do int I 0, I is less than nums.length, which you've done a bunch, plus plus I. Okay, so that's the loop heading, right? Just like normal. And then basically what I'm going to do in here is I'm going to do an if that basically if it is odd. So to check if it's odd, I'm going to take that nums position I that gets the number that's actually there. So that's going to get, right, that nums position I is going to get like the 3, the 2, the 0, the 4, the 7, right? And I'm going to say if that thing mod 2, so mod 2 equals 1, that would be odd, right? So if the remainder when you divide by 2 is 1, that's odd. Then I'm just going to display it. So down here, I'm going to do a system out print of nums position I. So that anytime it's odd, it's just going to print out that value. And again, remember there's elements or values and then indexes or positions. So it'd be a different question if I said display the odd indexes, right? The values at the odd indexes. This one says the odd values in the array. Okay, hopefully that makes sense. All right, so this is like a sample AP. There are this type level on the test. What is going to be displayed by this code? Okay, so K, basically I would look at what does K do here first. So K is going to start at 1 and go less than the length like normal. So 1, 2, 3, 4, let's see. So I should figure out the length here. I'm going to label these. So the length looks like it's 6 because there's 6 elements. So K is going to go 1, 2, 3, 4, 5, stay less than the length. Okay, and what happens each time is, so let's say K is 1, this becomes array position 0 compared to array position 1. So it's sort of like saying if the previous one is bigger than the current one, so if the 0 spot is bigger than the 1 spot, which it is here, 7 is greater than 2, then we're going to print out the position we're at, K, plus a space, plus the value. Right, so when K is 1, position 0 is bigger than position 1, right? So I'm going to print out K, which is 1, and then the value, which is at position K, position 1, which is 2. So it's going to print out position 1 value 2. Okay, then it's going to go to the next K value. So now K is 2, right? So I'll try to use another color here. So if K is 2, this would be position 2 compared to position 1. And in this case, this one is not greater, right? So it's going to skip over that, and then it's going to go to the next one. So now we're going to compare 5 to 3, right? So this would be 3 and 2, right? So now we're going to print out K, which is 3, and then the value that's at position 3, which is 3. Okay, and then it just keeps going. And anytime the previous one is bigger, it's going to print. So the next spot is 3 is bigger than 0. So we're going to print again. Right, so K at this point would be 4, I believe, right? And then the value at position 4 is the 0. Okay, and then the last time through when K is 5, the previous one is not bigger than this, so it doesn't print. So I think it would print 1, 2, 3, 3, 4, 5. Sorry, 4, 0. Okay. So this one, you can sketch out the algorithm. You might want to jot down a little code on this one too, because this is one of the code you want, something like this. So say that we have 4 test scores, and I want to be generous. I'm going to count the highest score twice. So how on earth would you do that? All right. So think about the algorithm, and then we could maybe talk a little bit about the code. Okay, so the algorithm, I would sum the elements, right? Find the max value, okay, and then add the max to the sum, right? Because we're counting it twice, and then divide the sum by num elements plus 1, because we have one extra thing that counts in our average, right? We have one extra score, so we have to add 1 right there. Okay, and I want to type up the code quick. If you want to do that yourself and then check against mine, that'd be real good practice for the test. So pause the video and try the code here quick. All right, so here's the code. I've got my array declared here. I guess I could have used ints instead of doubles, but I would set a max one starting. So basically this is going to track the max, and I'm going to just assume that the 0 spot is the max. I'm also going to make a sum right away, so I can do the max and the sum in the same loop. So basically, here's my loop. If I'm take the scores one at a time, enhance for loop, and if that score is greater than max, it becomes the new max. Add the score to the sum. Okay, and then we got to add the max because it counts twice. So I add it again down here, and then I divide by sum, and then scores length plus 1, right? And that will give us the average plus that extra max score. All right, that's it. Thanks for watching.